So tonight we're going to talk about batteries. Batteries are important, huh? Batteries have become more and more important in our lives as, portable electronics have become more an integral part of our lives, right? So batteries are just voltaic cells that are packaged in a way that makes them convenient as portable sources of electricity. There are many different types of batteries, and so the actual reactions that are occurring are going to depend on the type of the battery. I'm going to talk about these different types of batteries. I am not going to quiz you or test you on what are the half reactions for a dry cell battery. I'm not going to do that. This is more for your information, just to help you recognize how different batteries are different in some important ways. If nothing else, it makes you a better consumer. So dry cell batteries. These are really old school batteries. And you're like, well, why are they dry? They don't have a lot of water in them. Well, why would batteries have a lot of water in them? Car battery, right? Car batteries, lead acid batteries, they do have a lot of water in them. And so this was a development that made them lighter weight and easier to carry around. Of course, not big enough to use for a car, but the dry cell. And so we've got zinc is the oxidation, and MnO2 is getting oxidized. And between these two half reactions, we're going to get a voltage of 1.5 volts. So here's an illustration of this. We've got the zinc casing on the outside is the anode, and then on the inside we've got this paste with a graphite rod that is the cathode. So if you need higher voltage, you can put two or more batteries in series, connect the positive of one to the negative of the other, and run them in a line like that, and you can get higher voltages. If you have any questions, just interrupt. So alkaline batteries, this is what you would probably think of as regular batteries. And they're called alkaline, wrong button. They're called alkaline because it has a basic medium inside. So here we still have our zinc anode and a graphite rod in the middle for the cathode. But now we've got this, the chemical reaction is occurring in a basic environment instead of an acidic one. So the half reaction, I was supposed to write this together, huh? This says overall here, which suggests I'm supposed to add those together. I'm going to skip that. So here we also have MnO2, but now this reaction is a little different because it's basic. So these have a longer working life and last longer sitting on the shelf than the regular dry cells. This you might think of as a wet cell. These are the lead acid storage batteries, and these are what you'll see in regular cars, gasoline cars. So this is not a single cell, it's actually 6 cells that are wired in series. Each cell is going to produce 2 volts of power. Put them in series, they add up, so you get the 12 volts of power. You've got lead being oxidized and lead oxide being reduced. Yeah, you don't want these to leak. So inside here, the anode is a lead grid that is packed with like the spongy lead. The electrolyte solution here is going to be 30% solution of sulfuric acid. So that's going to be pretty corrosive. So when you see a lot of corrosion occurring on the terminals of your battery, that's usually due to a small amount of leakage, and that acid is going to corrode things very quickly. It used to be that you had to check the water level in your battery and add water sometimes, but now batteries are all sealed up, and so you don't have to do that anymore. So what happens in this reaction is that both the oxidation and the reduction half reactions are making lead sulfate. So that kind of, it's kind of weird. They're going in opposite ways to make the same thing. And that lead sulfate will coat the electrodes and prevent them from contacting the electrolyte if it goes on too long. So how do you get the lead sulfate off? You run the battery backwards. So that's what's happening as you're running your gasoline-powered car. There's something called the alternator, which takes some of the power from the gas engine and uses it to charge the battery, right? And that's putting energy into the battery instead of pulling it out. And so these processes are going to go in reverse, and then you'll dissolve the lead sulfate off of the surfaces. Any questions? So the lead acid storage battery is definitely a rechargeable battery. There's a bunch of other rechargeable batteries. One of them is a nickel cadmium or NiCad battery. So this one has cadmium, which is oxidized, and this nickel compound, which gets reduced. This has an overall voltage of 1.3 volts. Again, solid products are going to build up on the electrodes, but when you recharge the battery, running current in the opposite direction, it's going to regenerate the reactants. Overcharging is really bad for the battery because you want to regenerate the reactants, but then you don't want to keep putting electricity into it because you can cause unwanted side reactions, which are going to damage the battery. And so now most battery chargers are smart chargers, and they recognize when the battery has been fully charged and they stop, so they don't ruin your battery. But that did not used to be the case. So the alkaline batteries are going to have a voltage of 1.5 volts, and the nickel cadmiums are 1.3 volts. Nickel metal hydride, NiMH battery. So cadmium is toxic. It's considered a heavy metal, and so having a lot of these batteries, eventually they're going to wear out and they're going to get disposed of, and then we've got all this cadmium we have to deal with. So the nickel metal hydride has the same cathode reaction, but the anode reaction is different, so that you don't have to use cadmium. This is going to have a greater energy density. What that means is for the mass of the battery, you can get more energy. Or for the same amount of energy, the battery will weigh less, right? And so for portable devices, this is really beneficial. Lithium-ion battery. These are newer, tend to be more expensive. Again, high energy density. This is what you see in your cell phone, your laptop, your digital camera, things like that. So these batteries work differently. What happens is lithium ions are going to move from the anode to the cathode, which causes electrons to move through the external circuit. So here we've got graphite, and we've got this lithium transition metal oxide. And so the lithium ions are going to move in one direction or the other. This is also a rechargeable battery. Fuel cells are not technically batteries, but they are portable sources of energy. In a fuel cell, you have a reactant that actually gets used up. And then to recharge the fuel cell, you have to add more fuel into it. Unlike a battery, where to recharge the battery, you push electricity into it and cause the reactions to go in reverse. So hydrogen-oxygen fuel cell is the most common one. So you have hydrogen gas flowing past the anode. That would be a screen with a platinum catalyst on it. The hydrogen gets oxidized, the oxygen gets reduced, and the product is water, right? So this is great, right? We're going to use hydrogen and oxygen. We're going to make water. We don't have any nasty byproducts or anything. The problem is it's not really practical yet because you need a source of hydrogen. And so we need a better source of hydrogen. To keep this fuel cell going, you have to go to the hydrogen store, right? And get some hydrogen. Problem is there aren't any hydrogen stores right now. There's gas stations, but there's no hydrogen station. So we're still waiting on that. Here's an illustration of it. So we've got hydrogen coming in here and oxygen coming in here, and they're going to meet in the middle. The hydrogen becomes H+. The oxygen goes from a 0 oxidation state to a -2 oxidation state. And then hydrogen ions and hydroxide ions combine to form water. So, any questions about batteries? Yeah. So the question is it the H+ that's moving, or is it the electron? So it's the electrons. The electrons are moving. An electron leaves H2, or technically H2 is, one molecule of H2 is going to lose 2 electrons. 2 molecules will lose 4 electrons. Those are going to give up electrons. Electrons are going to go through here and be given to the oxygen. So the hydrogen ions are formed over here. Hydroxide ions are formed over here. This is an electrolyte, basically an aqueous solution. And so they're free to move, and they'll combine with each other to make water. Yeah.
Another one was the lithium ions.
Mm-hmm.
It said that the lithium ions move from the anode to the cathode. So in that case, the ion is the one that's moving, or is it still the electron that's moving?
Well, so you always have 2 things moving. So in the voltaic cells, what we were looking at before, we've got the electrons moving, and then we have ions moving through the salt bridge, right, to make up. Otherwise, you get a whole bunch of electrons stuck over here, and it's going to stop. So you need something to carry charge all the way through. And so for an electrolytic cell, that's going to be like your potassium and your nitrate ions in your salt bridge. Here, it's going to be lithium ions are going to be moving between. And in this fuel cell, you have the hydrogen ions and hydroxide ions that are moving in the solution. Yeah. Because basically what happens here is, the electrons coming through here, and now the oxygen here is going to be carrying extra electrons. And so that makes it an ion, which is going to be able to dissolve in this solution and float around. So this has the electrons, right? And it runs into this guy who's missing electrons, and they combine together, and now they're like, oh, hey, there's my missing electrons. So they're kind of reuniting there. So, batteries are really interesting, and there's a whole big industry in batteries, right? Trying to find things that are going to be safe to use and reliable, that when they're done with their usefulness, they're not going to be toxic and difficult to dispose of. You want them to be lightweight, have high energy density, and not cost too much to make. So there's a lot of factors involved in batteries, and I'm sure people will continue to come up with new ways to make batteries. Any other questions?